Okay, so let's continue with our next video in our coding exercise series. And in this video, we are going to solve next coding problem on the HackerRank, which is between two sets. It is also the easy category question, but it is something related to mathematical terms. But let's figure it out. So there are two arrays of integers. So we have two arrays of integers. So you could see like first array and the second array. Determine all integers that satisfy the following conditions. So we need to find the integers which are going to satisfy the two conditions. And what are those two conditions? The elements of the first array are all factors of the integer being considered. All right. So basically, we need to read this question multiple times to understand what the question is being asked. So there are two integer arrays, which is perfectly fine. We need to find some integers, okay, and we need to find those integers which are going to find some those two condition, okay. But what are those two condition? The element of the first array, so elements of the first array means 2 and 6 are all factors. What does it mean by factors? So let's go to the whiteboard. So when I say factors, factor means if I say 2 is the factor of some element, 6 is the factor of some element, it means if I am dividing particular element by 2, then the remainder is 0. If I am dividing particular element by 6, then the remainder will be 0. Then we are called 2 and 6 are the factors. So the question said the element of the first array means 2 and 6 are all factors. So it means to find, I need to find any such integer, right, any such integer here, so that if I divide by all the elements of A, that is 2 and 6, it will give me the remainder 0, right? And both the elements should be same, right? Okay, so that is the first problem. The elements of the first array are all factors of the integer being considered. Okay, what is the second condition? So let's read it. The integer being considered. So let's suppose here the integer will be, let's suppose we figure it out, 6. All right, so let's suppose we figure it out 6. So 6 divided by 2, 0. 6 divided by 6, 0. So we figure out, okay, there is a one integer 6. All right, okay. So we found one integer 6 using first condition, right? But will that be the answer? No. We have to check the second condition as well. The integer being considered. So this integer being considered from the first condition is a factor. Now it should be the factor. So what is a factor? Factor is that element which is going to divide some other element. So in the first statement, what it is being asked, we need to find those integers, the elements of the first array are the factors. So elements of the first array are the factors, right? In the second condition, we need to check that condition, the integer which we found, that are the factor of this. So it means if the integer which we find is considered a factor, so it means the number should be divided by that integer, right? So we should put here 6. All right, and let's suppose we should put here 6. So the integer being considered is a factor. So whatever the integer we figure it out, that will become a factor here of all the elements of the second array. So let's suppose we find 6. Then we will check whether 6 divided by 24, if we divide 24 by 6, will it give 0? Yes. If we divide 36 by 6, 0 gives yes. It means 6 is that integer which is going to satisfy uh, both our condition. And we need to find number of such integers. We need to find number of such integer. How many integer are there which are going to like justify these two conditions, right? Okay, so in the first condition this one, the second condition this one. Okay, So now to directly jump into the code, first figure it out how we can do using brute force. All right, because brute force is little easy, but let's see first brute force. So we need to find the element of the first array RL. So one approach is that start with all the elements, start with 1, 2, 3, 4. So let's pick one. Then we will say we will put one here, we will put one here, and we will check, okay, if 1 divided by 2 0, no. Then we'll try 2. If 2 divided by 2 0, yes. Then we see 2 divided by 6 0, no. Then we put 3. 3 divided by 2 0, no. Then we put 4. 4 divided by 2 0, yes. Then 4 divided by 6 0, no. Then put 5. 5 divided by 2 0, yes. Then 5 divided by 6 0, sorry, 5 divided by 2 0, no. Then we put 6. 6 divided by 2 0, yes. 6 divided by 6 0, yes. Divide means like basically the remainder modulus 0. So we found okay 6. Then we will check the second condition. If we divide uh, all the elements by 6, will it give the remainder 0? Yes. Then we found one element 6. Okay, then check with 7. 7 divided by 2 0, no. 8, 9, 10. 10 divided by 2 0, yes. 10 divided by 6 0, no. 11, 12. So one approach is that try to try to just go with all the numbers, right? Starting from the 1, but till where? Even if you go with all the numbers starting from the 1, but till which point? You can't say like 1 to infinity, right? So which point? So till what number we have to go? So if you see, what will be the maximum number we can put here in the first condition? What will the maximum number we can put here? All right. Or what will the minimum number we can put here? So if you see, if I put 1 here, 2 here, 3 here, 4 here, or 5 here, then first condition might be satisfied, but the second element will not be divided, right? The second element will not be divided. So it means the minimum starting range will be the maximum of these two numbers, maximum of these two numbers. So what I'm saying is in the brute force approach, I have to test all the numbers, right? So let's suppose 1 to infinity, I have to test all the numbers, right? But I want to optimize a little bit more because I don't want to try with all the numbers 1, 2, 3, 4, 5, 6, right? Because I know the starting point should be the maximum of this number. Because if I put here uh, any number less than 6, then this can be give this can like satisfy, but this second number will not going to be satisfied. As an example, if I put 2, so 2 divided by 2 remainder 0, which is fine, but 2 divided by 6 remainder 0, no. All right, so at least we need to put the maximum of the first number. So start will be the maximum of a, maximum of a. All right, so start will be the maximum of a. Okay, rather than starting from the one, we will like just a little bit optimizing, you can say. Still it is a brute force, right? Okay, so that is done. Now what will be the end point? Okay, so now what will the end point? So we see, okay, we are going to start from 6, because 6 will also divide by then 12 will also, because if we put 12 here, 12 by 2 0, 12 by 6 also 0, then 24 also, then 36 as well, right? So it could be infinite number now, right? And then maybe like 42 as well, like right? So but if I go till 42, will the second condition will satisfy? No. So what will be the maximum end point, like till which I will run the loop? So if you see, if I put here 36, let's suppose if I put here 36, second, if I put here 36, sorry, sorry, one second. So in the first condition, we understand we have to start from the maximum of 6, because if I put minimum, then this condition is going to fail. And till what point we are going to run? So till what point? Till maximum of, I think, not maximum, sorry, a minimum of 24 and 36. Because uh, if you go more than more than 24, like 25, right? So if you go more than 24, 25, will this condition will be satisfied? No. So if you put 26, no. 27, no. 36, even though this condition is going to satisfy, but this condition is not going to be satisfied. So and the range will be minimum of b. So and the range will be minimum of b. That's it. So now we know. Still, it is a brute force, because you put the charger on. Still we know, like, it is a brute force, but little bit optimizing. Okay, okay. Now we have the numbers. Now we have the number, right? And let the count will be 0. Okay, count should be outside. Count will be 0. Like, we have to find the number of integers. Okay, so we will start from the start. So we found, let's suppose we pick one integer, so we have to start from the 6, because uh, maximum of a6, we will start from 6. All right. So as soon as we start from the 6, what we are going to check? We are going to check whether all the element of a can divide 6 and give the remainder 0. If yes, then we can check with the second condition. If both the conditions going to satisfy, then I am going to increase the counter count by 1. So what we have to do is, I have to check. So first I have to, so whatever the number, so x is the number, right? Right. So I have to run a loop to check whether that particular x, if I put, if I just put like something like that, x divided by particular number from a array. So for I in a, right? For I in a, if that give me 0, if that give me 0 for all the elements, and if I put if for all the elements, right? So for I in a, for all the elements of a, whatever the number, let's suppose the first element is 6. If I put 6 divided by 2, 6 divided by 6, if everything will give me 0, then I am going to check the second condition. What is the second condition? In the second condition, I will put j and then divide modulus of x equal to 0 for j in b. In the second condition, one second. In the second condition, what I'm doing is, I'm picking all the elements of b for j in b, and then div and putting, like, in the numerator the element of b, that is the j, and in the denominator that particular element, that is the x, whatever the figure it out. And I am checking if all the elements will be divided. So as an example, let we start with the 6. All the elements will be divided, then we will increment the count, right? And we will return the count, right? So 6 will be done. Then in the loop, the next element will be 7. So it will check, okay, uh, it will check from the 7. 7 is going to fail with the if condition, so it will not even go further. Then it will check for 8, then it will check for 9, 10, 11, 12. 12 will be passed here, then it will check here as well. All right, it will go down here, 24 by 12, 36 by 12, then 13, 14, 15. So this is a brute force. Let's try to run that. Let's try to run the code. So sample test case has been accepted. Let's try to submit the code. So all the test cases hopefully has been passed. One is still running. Because it is a brute force, it is checking for all the elements, and because our range is still 100, then it will take some time. Yeah, so it is a brute force. So first we should know how you can solve the problem using brute force, because brute force is easy. Just check for all the elements. All right. Okay, now what is the next approach? So next approach is little bit something you should know something about math, like LCM and greatest common divisor, and you should know this formula, like GCD into LCM is equal to the product of two elements. If you know this formula, you may know or you might know. All right. So that's why I told you brute force is important. So at least you can solve the problem. It doesn't matter whether it's optimized or not. At least you have solved it. All right. Because optimize is always the second one step further. So I can show you the optimal approach as well. So in the optimal approach, what we did is, so let me show you. So here what we are doing is we are checking for all the elements, right? We start from 6, then 7, then 8, then 9. Why we are incrementing by +1? Why can't we increment by the least common multiple? Right, if we just increment by the least common multiple, then we are going to skip so many numbers and it is going to improve our performance, right? So same thing we did is here is, if you see, we find the least common multiple and the LCM into GCD is equal to X into Y. So how to find the LCM? So let me go to the dashboard. So LCM in GCD into LCM is equal to X into Y. So if you found to the LCM, this GCD will go down. So X multiplied by Y divided by GCD. So X, let me go to the code. So X multiplied by Y divided by GCD. So that is the formula for the LCM. And the GCD, we have the inbuilt module or function in the math, right? And how to find the LCM? So let's suppose you have some array, 2, 6, 9, 13, 14, so many number. If you find the LCM, so first you will take first two element, whatever the result will come, then you will check with the another, whatever the result will come, then check with the another. The same thing we are going to do is, so we take the first element, then we find the LCM using the first element and the second element. So whatever the result will come, we will we will put here and find the, check with the third element, fourth element, and then we found the LCM. Similarly with the GCD, we greatest common divisor, we we took the first element as a result, and then we will first and second GCD, whatever the result, second and third, because we can find the LCM for two numbers, right? So if you have to find the multiple numbers, so whatever the result will come, then you have to take it to the third number. So now you find the LCM and the GCD. Using that LCM and the GCD, you have to start with the multiple, that is the least common multiple, which is 6 in this case, and go with the GCD, greatest common divisor, right? Greatest common divisor. So maybe in this case like 24, right? Till GCD. But and we are checking if GCD divided multiply is equal to 0. And here, if you see, we are incrementing multiple not by one. We are incrementing multiple by the least common multiple, right? So we are skipping lot of numbers and then we are returning the count. So this is the might be this approach will not come directly into your mind, because it is something related to the mathematical function. One should remember this formula, right? So if they remember this formula, then there could be chances we can write, at least trying to write the code. But this is straightforward, easy, all right? Because while just reading the question, we know what we have to do. So that's it. That's the end of the video, and thank you.